complex lesions.
Thank you. So I'm going to discuss wire technology and techniques for complex lesions, and I would say that we could probably spend an hour each on these topics. I won't do that. Instead, what I'll do is I'll go over some basics of guide wires and then move into some concrete examples of wires I like to use in specific circumstances. That said, I'll talk about a few different wires, but I would point out that there are a number of wires from multiple companies: Boston Scientific, Abbott, Asahi. There's the whole range of wires we now have available, and so if you're not using a range of wires for specific applications, I encourage you to explore some of these wires to get to know them a little bit better. These are my disclosures. So the first thing I'd say about guide wires is I like to break them down into two main categories, and that includes workhorse wires and specialty wires. And that's, I think, a good way of initially conceptualizing wires. Workhorse wires tend to be our access wire, our go-to wire. You can generally do a good portion of the case with a workhorse wire. And a specialty wire, on the other hand, is something you pull out for a specific goal, a specific circumstance, tackling one problem in one small part of the case. So some examples of these: workhorse wires tend to be versatile, maneuverable. You can steer them, durable, give good support, and they're used for everything from access to sheath delivery to even delivering a balloon or a stent in an SFA. And they're kind of like our all-around wires. And some of the examples that I would typically use are listed here, including a stiff glide wire by Terumo. One of the workhorse wire on the 014 platform that I've recently discovered is the high torque Command by Abbott. This is an interesting wire that if you don't know, you should probably get a little more familiar with it. On the other hand, specialty wires are ones, again, that we pull out for a specific purpose. They may be very supportive to deliver a device. They may be very floppy with a very flexible tip so that you can put that tip way up into the intracranial circulation in carotid interventions. And they're really lesion-specific or purpose-specific. And this graph sort of highlights that point. As the case duration increases and as the case complexity increases, you're going to move from your workhorse wires, which you're using for a good portion of the case, to one of these specialty wires, which you may pull out for 5 or 10 minutes or even less to accomplish a specific goal. The other way to think of wires is to conceptualize them as the three basic platforms. And as surgeons, I think most of us are more familiar from our aortic work with 035 platforms. The cardiologists in the room are more familiar probably with the 014 systems and have a good experience with the breadth of these wires. And then the 018 platforms, I think, are important because in the past we only had a couple of these. Now we have a good range of these wires, and specifically some CTO wires that are very helpful for BTK applications. Which wire you use or which set of wires is in part personal preference and how you're trained, but I think there are also different wires for different purposes. That's true especially with the 018 platform, with the different diameter platforms as well. And I would say for the BTK space, really 035 wires are too big and too bulky and are used to deliver devices that are not generally appropriately sized for the below-knee space. So we tend to use 014 wires or 018 platform wires for the BTK circulation. Going over some basic wire technology, you can think of any guide wire you have as built of a number of about 6 different building blocks, so to speak. This includes the core diameter, the core material, the taper or the grind, how this core material is tapered as it approaches the tip, coatings and covers that are placed on top of the core, as well as coils, which give them radial opacity and allow you to have some better tactile feel, and then the tip style, whether the tip goes all the way to the core, goes all the way to the end of the wire, or whether there's a shaping ribbon or something of that nature. So these different basic building blocks or components give technical characteristics of the wire, such as support, torque response, lubricity, radial opacity, and these technical characteristics then generate the performance properties, what we know or what we feel as we're using that wire, the steerability, trackability, the feeling we can describe as we're trying to maneuver one wire versus another wire. So these guide wire components lead to the technical characteristics that then lead to those performance properties that we're looking for in a wire for a specific application. Just going over a couple of those real quickly. Core diameter is the diameter of the wire, and obviously the thicker the diameter, the more supportive and more torque response you'll get. The grind is important. A short taper or a quick grind will give you more flexibility and more of ability to prolapse right at that point. Tip style is important. Some of the CTO wires will have this core that comes all the way out to the tip to really engage the lesion, give you good penetration power, where others have a shaping ribbon that allows you to shape the wire, but also gives you more flexibility of that tip. So when thinking of an escalating wire strategy, this is kind of how I conceptualize it. First question is, am I dealing with a stenosis or an occlusion? And if I'm dealing with a stenosis, then the real key here is not to turn this stenosis, this high-grade lesion here, where there is a patent lumen, into a CTO by bluntly banging up against the intima here and possibly causing a dissection. For this type of application, your whole goal is to remain true luminal or intraluminal, stay within that lumen. And to do this, you want a wire that's maneuverable, has one-to-one torqueability. Generally, in the, again, BTK space, you want a low-profile wire. And typically, you want an atraumatic floppy tip, something that you can shape and steer through these stenoses. And a tapered tip is also pretty helpful as well. So one of the more advantageous wires for this application is the Asahi Fielder XT. This is a wire that's an 014 platform, but it tapers down to an 009 tip. So it's a very low profile tip that can engage and pass through very tight stenoses. It has a very low tip gram, 0.8 gram tip load. So tip load is basically the amount of force that it takes to deflect that tip of the wire. So it tells you how floppy a wire, and a low tip load is a very floppy wire. So it has a shaping ribbon, again, to give you some steerability to it, or give you a tip that you can navigate into a tight stenosis. Another very navigable wire is the Abbott Command wire, which I mentioned earlier. This is in as an 014 platform. Slightly higher tip load, but still not like our CTO wires. It's an interesting wire in that it's a stainless steel body welded to a nitinol core. With a somewhat of a gentle grind that will give you a fair amount of support even as you approach the tip. And this is another very navigable wire to steer through some of these tight stenoses. When you're talking about occlusions, it's a little bit different. Most of our occlusions we want to approach in a true luminal fashion, and so these are lesions like this, where you have the PT here that occludes down in the mid-lower leg, comes back above the ankle, and what you want is to engage this occlusion, try to stay centered within the true lumen, and basically stay within the center of that vessel. Unlike the SFA, where we're somewhat apt to go subintimally and take the path of least resistance, so to speak, there are a number of reasons why you want to stay true luminally within the tibials. And the goal for any intervention, any wire manipulation strategy, is to cross the lesion and re-enter the true lumen. In the tibials, it's much easier to re-enter the true lumen if you make some effort to stay within the true lumen all the way through. So some of the wires that are good for true luminal applications are listed here, and these are by and large our CTO wires. These wires have a number of properties or characteristics listed here. They tend to have supportive shaft or core material that gives these wires more pushability rather than trackability. So these are wires that are fairly stiff, fairly rigid. They won't navigate around tight, significant tortuosity, but they can really push through a lesion, and some of them even have tapered tips with a core that goes all the way to the tip that gives you that high penetration power. So penetration power is basically a function of the diameter of the wire and the stiffness of the shaft. And those with a stiffer shaft and a smaller diameter will have more force applied right at the tip of that wire. So these wires, like the Abbott Win 200T, this is a wire with, again, a tapered tip and a fairly supportive body in an 014 system. And the Connect 250T or the Estado 30 are similar in that they have a very high tip load and a very a tapered tip to give you that penetration power. The Connect series by Abbott, there's three wires. There's a Connect, Connect Flex, and Connect 250T. The Connect being much like a V18 wire. Connect Flex is similar to a Treasure 12 by Asahi. So these are, again, wires with 018 platform, a 12-gram tip load, a polymer jacket, and a very flexible, in the case of the Connect Flex, a flexible body but a fairly rigid or stiff tip. Another good and probably the ultimate in terms of CTO wires are the Connect 250T, the Estado 30, or the Victory 30, and these are wires with very high tip loads, so it's very hard to deflect this tip, and so it will sort of act like a spear as it engages the lesion and pushes through those. And again, this taper tip at the end of this very rigid wire helps with that penetration power. The way these wires are used, they're basically used with a support catheter. Here's a Cook CXI catheter down to the end of the wire. Basically, you want to bring the support catheter all the way down to your tip. These are used in somewhat of a drilling manner in which you're spinning the wire to try to engage the microchannels of the occlusion with that low-profile tip. One of the keys here to crossing these lesions is using not only a supportive wire, but a supportive coaxial sheath or catheter system, and that's demonstrated here where there's a 6-French sheath down to the distal SFA or proximal pop, a Cook 035 CXI catheter, through which I've telescoped a Cook 018 CXI catheter, plus the Connect 250T wire, which is, again, supportive wire. So this coaxial system really helps give you tremendous pushability. Now, unfortunately, sometimes even with that pushability, you can't find the true channel, and you have to go subintimally. And in the tibials, we, again, try to avoid that, but sometimes it's necessary. And these are some of the wires that I think are helpful for going subintimally in the tibials, using wires with floppy hydrophilic tips, low tip load, and a short taper so that it prolapses easily. So here's where this wire sort of met its resistance and couldn't go any further. Switched out to an 014 command wire, which makes a nice sharp J. Got this to pass down to the area of reconstitution of the vessel, and then pull the wire back into the catheter to straighten it out. And the very durable tip on this wire is very helpful. 2 final slides just to point out, reentry catheters are not as useful in the below-knee circulation. The one that can be helpful is the anterior catheter, is a 2.75 pontoon-shaped balloon that can help really at the trifurcation, I think, and maybe in the proximal tibials. But by and large, retrograde axis is the thing that we now use to navigate through a lot of these areas where reentry is an issue. So by directly accessing the lumen retrograde, we can achieve some more easy reentry into these cases. This is going to be discussed much more in the next couple of sessions. So in conclusion, effective wire escalation strategy depends on knowledge of basic guide wire components and the effect these components have on the wire's properties, and proper wire selection combined with the use of reentry catheters, or more importantly, retrograde techniques, can optimize chances of successful lesion crossing and reentry in BTK interventions. Thank you.